Greetings. Welcome to the virtual version of LogTech 21. I'm Dr. Albert H. Seegers, the PNC Distinguished Professor at the University of North Carolina at Chapel Hill. Today's topic is 7 technologies that are changing the world. This is based on research that I conducted over the past 5 years, looking for the most radical, the most life-changing technology that's out there and trying to somehow put that into a framework, to try to put it in terms of a framework that we could understand and draw inferences from it and perhaps identify opportunity. And that's what we're going to do today. We're going to look at these technologies, we're going to talk about them, and you're going to have a little homework along the way. I'll get to that in just a moment. So let's go in and take a look at the technologies that are changing the world. And away we go. Again, this is actually research that I've conducted, really consulting with a lot of the top organizations throughout the world. It started with Apple, started to talk to them, started to understand the type of technologies they were working on. It went all the way through to some of the most top technology companies in the world, IBM, Oracle, SAS, all the way through to startups, medical technologies. A lot of different things were considered. And when you think about the way that technology is evolving, if you think about how it's going to impact our lives, you start to realize that we are on the verge of an entirely new and very different technological revolution. Now, let me tell you why it's new. It's new because technologies are actually accomplishing things that seemed magical only a few years ago in the science of medicine, in sustainability, in commerce, in how we learn and how machines help us learn. These are all revolutionized. They're all changing. Plus, these technologies are converging. We are now going into an age of converged technologies. Interestingly enough, in the past, technologies were almost like islands, and we could identify them as such, and we could point them out, and never would they connect. But now we're in a world where technology is blending, it's converging, and you're going to see some of that. I call these converged technologies super technologies. And the things that they are able to do are truly magical, truly something that has not been seen ever in the history of mankind, womankind, or of earthkind, you name it. These things are just radically different. So let's go in and take a look at the research. It was published in MIT Sloan Management Review. I have to give a lot of credit to MIT and to the team at Sloan Management Review for helping me shape this research. It was a Herculean task. Imagine writing an article that will inform the readership of one of the top technology institutions in the world, MIT. It was quite a daunting task. It was an honor to do this research, and even a greater honor to see it published. So let's jump in and take a look at these technologies, and we'll get to that little bit of an assignment that I want you to complete as we go through the discussion. Well, if you take a look at how the research began and how we started to think about these technologies, take a look at the outer circle of this diagram. Commerce, health, learning, environment. This is basically a 4-dimensional representation of life itself. In any society, you will see these broad dimensions. You will see commerce, a way to exchange, a way to create value within a society where we exchange goods for services, for currency. All of these things have to happen, and that gives us a system of commerce. health is also very important, perhaps the most important thing in any society. We want to make sure that we have good technologies, that we have good systems and good procedures for health. And that's an important aspect of any society, of, um, of any great group of people that have done amazing things, is certainly health. Learning, the ability to evolve as a society, the ability to acquire new knowledge, the ability to determine when knowledge is not accurate, when facts aren't supported. That's a real key piece of any great society, the ability to learn. And of course, the environment. Any good society is going to take care of their home. They're going to make sure that air, water, land, the natural resources are taken care of, and that society has a sense of order and opportunity for itself. That's really important in thinking about how technology can change things. So that outer circle gave me the definition of life itself. In order for a technology to qualify as being life-changing, it had to be positively affecting all four of those things, radically remaking them. And as you can see, this resulted in 7 buckets of technology. Now, importantly, each one of these technologies is not a single technology. It's a bucket of technologies. It's a collection of technologies. And here you can see the list. So let's start at high noon. Biotechnology. This is the application of technology to living cells, to us as living beings, to the plants, to any living system. Biotechnology impacts that. Wireless mesh networking. This is our communication technology, our bucket of communication technologies. High-speed wireless technology that's radically changing the world around us. Nanotechnology. This is non-organic matter. So these are things like metals, steel, fiber, fabric, things that are non-organic but are enhanced or changed by technology. Advanced robotics, a surprise to me in terms of being the researcher for this project. I myself am sort of an expert in machine learning and robotics. That's where I really started my career right out of college, and during college was programming robots. I was surprised to see it appear as one of the life-changing technologies. I wasn't expecting it, but it's there, and it is radically changing the world around us. Machine learning, everybody's talking about that. Artificial intelligence, machines that help us make decisions, that help us gather data, that help us visualize data. This is an important aspect of technology. We're at the starting line of what machine learning is going to do in terms of helping us to understand knowledge, to help us understand statistics, and to make better decisions, to make decisions that are based on fact and not based on bias, are based on falsehood. That's what machine learning is doing for us. 3D printing, I think, is the most popular. It's certainly the one that gets the most spotlight. 3D printing is the idea of manufacturing something on demand in highly customizable form. It's really a chemical revolution and a computer revolution. And there in the middle is pervasive computing. Pervasive computing is taking what was once in the box, what was once something that sat on our desk or sat with us or was stable, and moves it out into the world around us, where we have digital technology in the windows of our house. We have digital technology in the clothes that we wear, the glasses that we wear, perhaps even within ourselves. We might have some of this pervasive computing technology. I know that sounds a little far-fetched, but it's where the technology is going. So what we're going to do in this segment is go through each one of them. I'm going to show you some examples. I've got some video that will actually show you where a lot of these individual technologies fall within the buckets. And we'll also talk later on about how these buckets are converging, the convergent technology piece, or like, as I call it in the article, super technologies. So let's now turn to what I want you to do as you watch this segment. Well, let's take the aspects of logistics, just the broad aspects. And you can see that represents the rows of this particular matrix. Design and decision making. How are logistics designed? How is decision making determined? Acquisition, the procurement, acquiring of material. Storage, this is material at rest, where it rests. How much is in storage? How much is in the supply line? Distribution, how we move material through a supply chain. Transportation, the technology that carries material from one place to another, air, land, sea. And of course, maintenance, how we maintain the material that we move, the assets that we're responsible for. So think about these 6 broad dimensions of logistics. Now let's look at the columns. Notice here that each one of these is one of the 7 technologies: pervasive computing, wireless networking, biotechnology, 3D printing, machine learning, nanotechnology, and advanced robotics. Here's your task. And I think it's a fairly easy task. And it's one that I think you'll find fun, because what we want to do is try to identify opportunity. Your task is to score each box in terms of its impact. Now you're going to put your impact score in the top left-hand part of the box. And the ability to implement. How easy or how difficult will it be to implement within that box? Now, as you score these boxes, you're going to come up with ideas. There's going to be something in your mind that says, well, we could do this. I want you to keep that thought, but for now, let's just put the scores in there, because what we're going to do is we're going to gather all these up, and we're going to see where the biggest and the best opportunity might be, and how difficult it might be to realize that opportunity. Well, that's number 2, the ability to implement. That's going to be on the bottom right. So in that particular score, what you're going to do is try to understand how easy or how difficult will it be for us to implement ideas within that box or opportunities within that box. What we're trying to do is counterbalance here. There may be something with tremendous opportunity, but it may be very difficult for us to implement. There may be something that has very, very low impact, but we're able to implement it quite easily. We're looking for these paradoxes. We're looking for these consistencies as well. So let's take a look at the scale you're going to use. From 0 to 4, impact. 0 being no impact. There's nothing to be gained here. And that can even mean that we're just not ready for it yet. 1 is low impact, 2 moderate impact, 3 high impact, 4 the highest impact. I don't want you to be too concerned with accuracy so much. Think about it in terms of where the neighborhood that you think it might be in. So in decision making and design, pervasive computing, block number 1, row 1, column 1, we might score that a high impact. Maybe we think that pervasive computing technology is a 3 there, but because we have existing technologies, we have existing processes, it may be difficult to implement. So I might score that a 1 in the bottom right-hand block there. So give it a score based on what you think the impact will be and the ability to implement. You have a score sheet that's been provided to you in Canvas. As I go through the discussion, just give it a score. As these ideas come about, as we go through each technology, where do you think the impact is, and what is our ability to implement? So that's your work. That's what I want you to do as I walk you through each one of these technologies. Okay, with all that set up, let's go in and dive in and take a look at each one of these technologies. Technology number 1, pervasive computing. You know, many times you can think about this as the Internet of Things. In the article, I call it the Internet of Everything. Basically, what we're doing here is taking computing, processing, and communication, which has been in a box, and we're taking it out of the box. Now it is in the world around us. As I mentioned earlier, in the clothes we wear, in the devices that we carry, in the windows that we look through, in the windshield that we peer through as we drive our cars. It can be in the watches we wear, in the glasses we wear, for those of us that still have to wear glasses. Thinking about how we take computing and move it out, away from the box. When we think about the design concept for this, the idea here is, number one, on the far left there at 7 o'clock, natural interaction. That this technology works with us. It is something that is not intrusive. It is not something that is laborious for us to carry around. It has very much natural interaction, voice commands, touch, even the movement of your eyes might be something that signals a command to these types of devices. Ubiquity, the idea that it moves with us, that it's ambient. In fact, I'm going to show you some really incredible examples of ambient devices. Things that work in the background, things that blend in with the world around us. That's ubiquity. Proactivity, to me, is one of the most exciting aspects of pervasive computing. That technology is aware of our context. It's aware of our activity, and it models our behavior. Now, I'll give you one example of this for me. I wear an Apple Watch. Doesn't mean it's the greatest in the world, but it's something that I like, and I have a lot of consulting and practical experience with Apple. So I wear Apple Watch. So think of this as a promo for Apple Watch. One of the things that I follow quite a bit is my workout rings. It will signal me if I'm behind on my workout. It will tell me that I need to get with the program. And it works. It absolutely works. If I get to the end of the day and I lack some exercise to complete one of the rings, I will get up and walk around or get out and take a quick walk so that I can complete the day knowing that I accomplished my goal. It's very proactive. It's telling me how I'm doing. It measures my heart rate. It measures a lot of things about me that tell me how I'm doing in terms of my physical goals. So that is an aspect of proactivity that we certainly see in a lot of today's devices that we wear. And again, it does have natural interaction, the touch, and ubiquitous. It moves with me. It's part of my everyday wardrobe, if you want to think of it that way, or my everyday walk. So it's interesting to think about these different technologies. Now, where will it show up? Number one is the wearable, just what I'm talking about there. One of the more exciting aspects of this are the wearable lens, where we can visualize, where we can help design using wearable technologies. One of the great technologies out there now, and there are going to be more. Believe me, we're just at the starting line of where this technology is going to be, is Microsoft HoloLens. And this is a technology that is absolutely incredible in terms of VR, AR, and design. So let's take a look at this technology.
Microsoft HoloLens brings holograms into your real world. Using transparent lenses, spatial sound, and an understanding of your environment, holograms look and sound like they're actually part of the world around you. That is mixed reality. With Microsoft HoloLens, holograms are viewed through the holographic frame centered in the middle of your view. This preserves your peripheral vision, so you can move freely and connect and collaborate with people around you. Holograms in mixed reality don't block out what you can see and hear. This enables you to engage with digital content and tools alongside the objects in your real world. Holograms can be world-locked in a physical location, so you can walk around them, or they can travel with you. You can even hear them in 3D with spatial sound Microsoft HoloLens is the world's first fully untethered, self-contained holographic computer. With the mixed reality experience of HoloLens, you can stay in the real world and interact with real people as you simultaneously explore 3D in 3D.
Amazing when you think about what is possible. Here is another prototype of wearable technology. This is actually, I believe, a Galaxy phone that is wearable. And you can see, which is interesting about this technology, it's very, very thin, moldable type of technology, and you can see the person's skin underneath it. So it has some aspect of transparency. This type of technology, again, can be moldable to your wrist, to your thigh, around your ankle, wherever you want to wear it. So this might be the next design of your mobile device, something that is wearable and able to actually capture your vitals more quickly and more accurately because it is nestled right there on the skin. One of my favorite technologies in this class is ambient technology. Ambient technology is really information, digitization, commerce that is all around us. And it's technology that interacts with us. One of the leading technologies in this is OLED. OLED basically is bendable, moldable type of displays that are incredibly vivid and certainly highly mobile, and they make use certainly of wireless communications that we're going to talk about next. So let's take a look at OLED and take a look at the future of ambient technology.
The birth of display was the beginning of a new world. In the world that was revealed by the display, we saw a brighter future. We have turned imagination into reality. We have finally opened up a new realm of innovation for OLED after overcoming numerous challenges through our passion. We will make this new world with values that rise above the technology we have known so far. Display, which broke away from the limits of form, more freely overcame the hindrances of expression to expand the value of beauty into a realm of creation close to an art. While substituting for familiar functions and emotions, we are continuing to imagine through infinity. A window of communication which allows mutual understanding beyond the visible world. It always leads us to selecting the best by swiftly reacting, even at unexpected moments. The unlimited evolution of technology turns all imagination to a display into reality. Our old dreams of getting desired information have just all been realized by wearable devices. More satisfactory routines are made to be enjoyed by always providing optimum conditions. Furthermore, our desired values are provided anywhere and anytime through thinner and lighter forms. Interface without gap between humans and technology. As OLED technology enters into our environment and forms, our work and life will be made anew even further. And at the end of all the changes, our dreams will be realized. Although the display is evolving ceaselessly, our never-changing values will continue to be projected toward human beings. A sheet of display will wrap around even our hearts and contain values of communication and healing to get us closer to fulfilling our dreams. An amazing and precious experience where desires are unfolded and all emotions in that space are conveyed through the 5 senses. While we nourish the happiness of the next generation in this way, we will advance to this new world. The future, dreamed of by everyone. The technology that's making that future a reality. OLED will be opening up beyond everyone's imagination.
Wow, that is pretty amazing. And you know, I think I have to say that of all the technologies in pervasive computing, that one just tends to be my favorite. I think it's just absolutely fascinating what is possible. Now, notice that it is hitting all of those important aspects of pervasive computing. It is proactive. The display is something that reacts to human interaction. And it's very, very mobile. If you notice the tiles that were moved around, they're absolutely amazing in terms of what is happening within the space of pervasive computing. Well, that brings us to even more advanced types of displays, something that is really emerging out there, and it's holographic display. One of the companies that is really interesting in terms of taking holographic displays and making them something that goes into our normal computer displays is the Looking Glass Factory. One of the things that's really interesting about this is that it's able to really give us richer sources of information. We're able to see more. We're able to determine more, and we're able to design more when we have holographic types of displays. So let's take a quick look into the Looking Glass Factory.
This 8K holographic display can show 3D content from 45 unique perspectives, with no headsets or special glasses required.
I've had this dream of a holographic display since I was a little kid, and first saw the shark gobble up Marty McFly in Back to the Future 2.
We visited the Looking Glass Factory in Brooklyn, New York to learn all about their 8K immersive display and what the future looks like for this emerging new category of holographic video.
If you think about any screen that's ever been made, all of those displays run off of pixels that have 2 properties of intensity and color. But the real world, like this DeLorean I happen to have here, is real to us because the light of this room is bouncing off of the glass and plastic and rubber with a 3rd property of directionality.
Moving side to side, you can see how the light reflecting off the objects in the display changes based on the viewer's perspective. Lenses and magnifying glasses viewed through the 8K immersive display also illustrate how Looking Glass's light field technology mimics the behavior of light as it interacts with real-world objects before arriving at your eyes.
So we make all the optics and electronics for the Looking Glass product line that essentially sends out, in some cases, like in the case of the Looking Glass 8K, 100 million points, and controls the directionality of those 100 million points to generate a synthetic light field, which in non-nerd language just means a hologram.
The Looking Glass displays have about a 40 to 50 degree viewing angle. Once you step outside the viewing cone, the image flips and distorts a bit.
We like to think of the Looking Glass product line as kind of the Switzerland of the AR, VR, hologram universe, where we can take any type of 3D input, and we built enough software infrastructure so that the Looking Glass can run all these types of three-dimensional information. That also is represented in how we can work with any type of peripheral. Really any way that folks have developed to interact with three-dimensional information, from the 2D computer field all the way up to what's been done in VR and AR landscape, the Looking Glass supports that.
The display updates at a rate of 60 frames per second, pretty standard for most computer displays and TVs.
Even though there isn't a lot of 8K content out there for flat screens, there's a lot of three-dimensional content. Our software infrastructure has a camera, essentially, that takes dozens of different views of that three-dimensional scene, bundles them up into a video signal that then is deconstructed by the optics and electronics of the Looking Glass itself, so that we can pull all of those perspectives from a virtual environment into the real-world environment through the Looking Glass. This illustrates kind of how the light field processing is done in the background in a lot of our software. So the Looking Glass can really do anything that is in a totally virtual environment, but also capture and then replay the real world with a really high level of fidelity.
The Looking Glass Factory's 8K immersive display might be their latest and largest holographic display, but it isn't the only option. The Looking Glass has an 8.9-inch version and a 15.6-inch version, which range in cost from about $600 to $6,000 depending on the type of package you get. These smaller desktop displays are aimed at developers, while the 8K immersive display is aimed at specific industries like medical imaging, holographic mapping, and scientific visualization. Folks interested in the 8K version will have to reach out to Looking Glass directly through their website for pricing information.
I believe, and all of us here in our team believe, that the step that comes after 2D computers and 2D screens is a holographic step primarily. One of my special dreams, and my co-founder Alex's dreams when we started the company, was the idea that you could have a Looking Glass here in Brooklyn, and we could have one maybe in San Francisco or Shanghai, and between those two Looking Glasses, it would be like you poked a hole through the earth, and you could share a few feet of space with somebody as if they were sitting right across from you, but in this case through a holographic Looking Glass.
What would you do with a holographic display? Let us know your thoughts, dreams, and opinions down below. Thanks to my colleague in New York, Marta Franco, for visiting and filming the Looking Glass Factory for us. Thanks to YouTube commenter Gilotopia for suggesting the Looking Glass 8K display for a WTF video. And thanks to you all for watching.
It's really amazing when you think about what is possible in holographic displays. Here's another example which is really interesting. Elevator buttons that you don't necessarily push, they're holographic images that you interact with. Now think about this in the era that we are now in with concerns about health, pandemic, how this might change the way we interact in terms of calling an elevator or punching in a code. Really gives you some idea about what is possible. You know what's really interesting here? We really just scratched the surface of what's possible out there. Within this bucket, there are lots of different technologies, hundreds of technologies, hundreds of companies that are pursuing different things. So as we go through this, think of this as a greatest hits. It's really the tip of the iceberg in terms of what pervasive computing will be. Well, I hope that you're filling out your display and for filling out your worksheet and starting to get some ideas about what might be possible in terms of these technologies and their application for logistics. Let's take a look now at wireless edge networks. One of the things that is really, really interesting, and one of the things that has been quite a bit difficult, to be quite fair about it, is trying to get stable, consistent, and reliable wireless communication. There's a reason for this. Let's take a look at some telecommunication basics. If you take a look at any wireless signal, we can place it on the frequency spectrum. Take a look at this diagram. Hertz, kilohertz, megahertz, gigahertz, terahertz. These are displayed on the vertical axis of our little graph here. And basically all this measures is cycles per second. Kilohertz being thousands of cycles per second, megahertz, millions of cycles, gigahertz, billions of cycles, and terahertz, trillions of cycles per second. And you can see this illustrated right there in the middle of the graph. A cycle is when a wave begins or ends. What's really interesting about a radio wave is that we can encode a 0 or a 1 or a digital representation at the peak or valley of that particular wave. So the number of cycles per second, we can almost think of that as an approximation as number of bits per second. So doing this, we can think of kilobits all the way to billions of bytes or bits per second traveling on a radio wave. Now, let's take a look at some facts about radio waves. They travel at the speed of light, a little bit less around obstructions. Radio waves can range from 30 hertz to 300 gigahertz. Now, what we know just from our previous discussion there, the higher the hertz, the greater the amount of data that can travel on the radio wave. So we can think about that as bits per second and moving that from 300 hertz to 300 gigahertz, 30 hertz to 300 gigahertz. Here's the paradox, and this is the problem. The higher a signal rides on the frequency spectrum, the greater the bandwidth. That's good. So as we move up the vertical axis to gigahertz and terahertz, we know that that's translating to more bits per second. This is a good thing. However, here's the paradox. The higher a signal rides on the frequency spectrum, the shorter its distance. That is a problem with physics. So we can place a signal very, very high on the frequency spectrum in gigahertz or terahertz range, but that signal will not travel over a greater distance. That is the paradox of wireless communication. So in order to ride higher on the frequency spectrum, we have to bring devices closer together. You have to be closer to that cell tower in order to achieve that type of speed. The march that is going on right now is to try to give us 5 gigahertz. I'm sorry, to try to give us 5G, erase that, 5G speed, which really moves us up the frequency spectrum. However, to do that, we have to move devices closer together. And that is the heart and soul of wireless mesh networking. Here you can actually see these different bands translated onto where they fit on the frequency spectrum. If you take a look at the bottom band, VHF, UHF, all the way through to THF, you can see where they ride on the frequency spectrum. You can also see in the middle the IEEE band there, where K bands are, V bands, C bands. So you'll hear this talked about quite a bit, that it's a K band signal or a C band signal. Don't be intimidated, just know that's where it rides on the frequency spectrum. If we turn this into devices themselves, take a look on the left-hand side of this diagram. Maritime radio and navigation really travels at VLF, which is low frequency. That's because it can travel greater distances. So if we're out on the ocean and we're transmitting ship to ship or ship to shore, we can do that at a low bandwidth, or we would want to do that at low bandwidth because we know that signal will stay together longer. Same is true for submarines. As we start to move to the MF frequency there, notice that, you get into AM radio. FM radio starts at VHF. Now, one thing that you'll notice, if you remember, AM radio does not sound as good, but it travels over longer distances. FM radio sounds a lot better. It's riding higher on the frequency spectrum, but it will not stay together. The signal will not stay intact over longer distances. Satellite communications gets higher into the 3 gigahertz to the 30 gigahertz type of frequency there. So it gives you some idea, this gives you some idea about how devices are placed along this frequency spectrum. So the name of the game in the telecommunications industry or the wireless communication industry is to achieve higher bandwidth by trying to place devices, towers, and satellites closer point to point. And one of the ways we've been seeing this done is in satellite communications. What's really interesting, if you park a satellite 22,000 miles above the Earth, it will stay in orbit around the Earth. And we can travel, we can place a signal at a fairly high bandwidth on that frequency spectrum. And that satellite will stay in geosynchronous orbit. And that's what we call these, geosatellites, a geostationary orbit. Not bad. However, if we want to increase the bandwidth, if we want to move higher on the frequency spectrum, we need to take that satellite and move it closer to the Earth. When we do this, it's called a LEO, a low Earth orbit satellite. The footprint of the satellite on the Earth will not be as great. It will not cover as much of the Earth when we move it closer. However, we move higher on the bandwidth. So what happens in that scenario is we have many more satellites up into the air, but they're at low Earth orbit. Another problem is that these satellites will not stay in geosynchronous orbit and will eventually burn up in the atmosphere. So to achieve this, you have to have a lot of satellites and you have to have a lot of technology to try to keep them up in the air. Well, Elon Musk has come up with a technology and a business model to achieve just that. And it's called Starlink. So let's take a look at this initiative to bring satellite technology to the level of 5G by moving satellites closer to the Earth.
If you've been looking at the night sky in the last couple of weeks, you might have thought, is this an alien invasion? Little star-like dots are moving through the sky, neatly aligned, one after another. But don't worry, what might be mistaken for UFOs are actually satellites, created by this guy, SpaceX founder Elon Musk. The satellites are part of the global Starlink project, which aims to bring high-speed internet even to the most remote corners of the world. That might sound noble, but is it really? Let's have a look and find out what's behind the Starlink mission and how it might benefit you.
1, 2, 3, 4.
Starlink is a project by SpaceX, Elon Musk's very own aerospace manufacturer. Starlink has been in the making since 2015. That's when Musk announced that the company would start developing their own satellites. They were formerly focusing on carrier rockets. By 2018, the first 2 prototypes were launched into space. And in May 2019, the first set of satellites was sent into low Earth orbit, properly transported by SpaceX's very own Falcon 9 rocket. As of April 2020, SpaceX has launched over 400 satellites. But this is only the beginning. They plan to build a network of as many as 12,000 satellites over the next decade, meaning that we will be seeing more of these little light dots in the night sky. Reason enough to address some pretty important questions. How do we benefit from the Starlink mission? What's in it for SpaceX? And what are the risks? Here's what you need to know. In order to understand the benefits of the Starlink satellites, you need to understand how they work. Each satellite weighs about 250 kilograms and is packed with technology. It's essentially a flying, solar-powered, wireless rudder. Perhaps the most interesting bit of tech on board is a set of lasers. They are performing an important job called backhaul communications. That means they're linking nearby satellites together optically. Optically meaning very similar to the way optic cables transfer data, just without the cable. That way a massive space network is created, much like the submarine communication networks of fiber optic cables that is the backbone of our internet at the moment. If you want to learn more about that, click here and watch our recent tech explainer on how the internet works. Shooting information through space rather than through fiber optic cables has one significant advantage. Light travels twice as fast in vacuum than in glass, meaning faster internet. This leads us to the first real benefit of Starlink. The company wants to make their high-speed network as accessible as possible. Musk claims that users will only have to buy a pizza box-sized antenna, which supposedly will be very easy to set up. Unfortunately, there hasn't been any more information on how much this receiver will cost. A high-speed network in space and a low-budget antenna on Earth. Sounds good. But the big distance means the communication between antenna and satellites will take longer. That is actually the problem most traditional satellite internet providers have. It's also one of the reasons why satellite internet has never really had its breakthrough. Typical communication satellites operate in geostationary orbits at an altitude of about 36,000 kilometers. The Starlink satellites orbit the Earth at about 550 kilometers, which decreases the latency dramatically, meaning the time between impulse and response is shorter. The fact that the satellites are closer to Earth also means you need more of them to cover the whole planet. If you want to know why that is exactly, we made another video about internet from space that explains it. Just click the link here. To sum it up, in theory, Starlink connections have the potential to greatly reduce the latency that exists in terrestrial links, and by doing so, make high-speed internet accessible everywhere.
So it's kind of interesting when you think about how this will translate into 5G speed. In terms of what 5G is, you need to think of this as like combinations of technologies, all with the same goal, trying to move communications up that frequency spectrum, trying to move it from megahertz up to gigahertz. That's the goal there, and to create reliable communication. So that's the idea behind 5G. What you saw there, low Earth orbit satellites and the Starlink network is part of it, but it will also be augmented by fiber optic networks, by point-to-point mobile communications. So let's take a look at the entire architecture of a 5G network. As shown in this diagram, it's many technologies. There is a core network that is surrounded by what we'll see later, edge networking, where telecommunications is moved in pods, if you will, where devices are close to cell towers. Those cell towers then communicate with each other, point to point. Sometimes it goes to ground in fiber optics from one tower to another, but it's a combination of these things that will really create the next form of wireless networking known as 5G. So let's take a look at it.
"5G is the fifth generation of wireless data networks, and it will improve them far more than 4G or 3G ever could. You'll feel it in your phone, your home, your car, and in the city and town around you. Downloads and streaming should happen literally without delay. Cars will talk to each other to prevent collisions. An untethered augmented and virtual reality can finally be achieved with real-time response. Not to mention industrial benefits like remote surgery or drone control. 5G does its magic with three key abilities. First, high bandwidth. 4G could only muster about 200 megabits per second of data throughput on a good day. 5G can handle up to 1 gigabit or more. That's 1,000 megabits a second on up. Low latency. 4G suffers from around 100 milliseconds or so in response delay or latency. 5G reaction time can be as low as 1 millisecond, which makes everything happen virtually instantly. And dense connections. In a given square kilometer, 4G could only manage to connect about 1/10 the amount of devices as 5G can. If that's some of what 5G does, how does it do it? 5G uses new radio technology, the part of any wireless device that makes the connection. 5G uses some radio frequencies in a band known as sub-6, from 600 megahertz to 6 gigahertz, part of which is also used by current 4G LTE. But 5G will also use a higher band of radio frequencies, from 24 gigahertz to as high as 86. These much higher frequencies bring with them much higher data rates. Now, while these new 5G radio waves can carry more data with higher performance, they can't carry it as far. So 5G will use a lot of so-called small cells. These are small versions of the big cellular towers we all know. 5G will also use some new tricks in these small cells, like beamforming, to efficiently aim transmissions rather than just spray everything everywhere. The bottom line, though, you will need new phones, tablets, portable hotspots, and the like with a 5G radio inside to connect to the new 5G networks. Your current 4G or even 3G gear can't tap into it. 5G networks will also position more data and computing resources closer to you that will avoid blunting 5G's low latency benefits. Most of us do think of phones when we think of wireless networks, but phones may actually be the least interesting thing about 5G. It will also power autonomous cars, so they have awareness of every other car, bike, pedestrian, and traffic signal around them. Smart cities based on 5G can make almost anything that's electric also connected and aware. When a bridge needs repair, why can't it tell someone? With a mesh of 5G connected sensors, it could. And then there's your home. 5G will offer a new way to get internet there, eschewing cable or DSL, and one day maybe even obviating your Wi-Fi router altogether, as devices may just use 5G natively to connect directly to a wireless ISP. 5G has renewed concerns about the safety of cellular radio waves. Some cities have taken action to block 5G deployment. Health questions come up around 5G's use of microwave frequencies, lots of them as we've seen, thanks to that large number of small cells that will be installed around us. Now, while 5G may sound like a lot of microwave ovens mounted on poles running with their doors open, in fact, microwaves are nothing new. Already emitted by your current smartphone, old cordless phones, your wireless headphones and earbuds, and just about anything with Wi-Fi, as well as, yes, microwave ovens. But even 5G's highest frequencies are considered by scientists to be non-ionizing radiation. You have to move on up to X-rays, gamma rays, and cosmic radiation to find the kind of emissions that will harm cells, and 5G is far below that. 5G follows the inverse square law, losing power rapidly at even a small distance from the small cell. The US CDC says there is no scientific evidence to provide a definite answer to the question of cellular radio wave safety, whether it's 3G, 4G, or 5G. 5G will take years to roll out and some investment on your part, but the complexity of that deployment and debugging should be worth the wait, delivering the world we've been promised for a long time, where everything is connected, aware, and responsive, and a world in which we can stop worrying about the availability or performance of connectivity in the first place.
Well, that gives you a great overview of what 5G is. And you see some of the basic principles of network communications there, particularly the wireless network communications. The idea that these micro towers will have to be closer to devices. One thing that I will add to that is also the use of fiber optics. So certainly if you're someone who's followed the progress of Google Fiber or AT&T, these fiber networks will also be a big part of delivering that high bandwidth. So it's not just wireless, it's wireless that might go into a tower, tower going into fiber optic then bringing it back out to the tower. Well, that leads also to another aspect of computing that's really interesting, and that's edge computing. The idea here with edge computing is that not only do we have remote technology in terms of communications, but that we also process information at the edge. So the idea here is that perhaps someone that wishes to exchange money with you, perhaps you purchase something, that can be done between two devices. The money can be transferred to you via Venmo, and it's done without going to the main grid or going into the internet. It's done device to device. So it's almost like taking $20 out of your wallet and handing it to somebody. It's that very same thing done remotely. You don't have to go to the bank, withdraw the $20 and give it to the person that you want to have the money. It's done very much at the edge. And that's really something that perhaps will change a lot of computer architecture, transactions, and the way we think about the world around us. So let's take a look at edge computing.
For a lot of the biggest trends in technology that we hear about, edge computing is going to be a necessity. So by putting these edge devices, whether it's like we have on cell phone towers today, or actually putting them inside an autonomous vehicle, you're able to do things that used to be impossible to do before just because the cost of sending the data there and back was too much and processing all of it was too much, or the latency wouldn't enable the technology to take off. So there are a lot of use cases for edge computing, some of which are starting to be in use today. For example, in autonomous driving, how this would work is there are sensors already all over these cars, even on a car that you just buy today, that can tell you when you're backing up if you're getting close to something. But if you take it a step further and you think about the autonomous world, you're going to have a lot more of these sensors on the car. But for the sensors to provide the value that they need to, you really need to have a device that can process the information that's coming in real time. So if you were in a snowstorm and you're an autonomous vehicle and all of a sudden you couldn't get that internet connection, it becomes a potentially really dangerous situation. So the way we think of it is having these edge devices that would be built into your autonomous vehicle to help make sure that the vehicle's getting the updates that it needs. In factories today, you're starting to see people use these types of edge devices where it can help predict if a device or if a machine is going to start to see failure. It can start to see anomalies in how the work's getting done or how a piece of apparel might be getting made. And jet engines do this as well. That's another example of where you can use these types of sensors where you need to then gather the feedback, right, and monitor the feedback that you're getting. But you can get those data points to figure out, okay, there's something that we need to check before a problem ever arises. So when I think of the opportunities that lie ahead from all of these exciting technologies that are going to change the world that we live in on a daily basis, I think of edge computing as playing a pivotal role. And in my view, it's not a matter of if that happens, it's just a matter of when.
Wow, what a great overview of this idea of edge computing. I really think that's going to be one of the more important sub-buckets of the wireless networking revolution. The idea that devices can coordinate, they can collaborate, and they can reconcile at the edge rather than data flowing back into the grid. Again, think about it as giving someone a $20 bill out of your wallet, wherever you may be, versus having to go to the bank, withdraw the $20 and then give it to the person. You're working at the edge. Well, this really gives us, kind of introduces us to another aspect of mesh computing and wireless technology that's really interesting. And of course, that's drones and remote sensing. This is going to be a huge aspect of transportation, parts delivery, and perhaps distribution. Already being incorporated here in the Research Triangle area with UPS using this type of technology to deliver medical samples across hospital campuses. This is really important, certainly when time is of essence. You want those lab samples to be delivered accurately, and you want them to be delivered efficiently. And that's what's being done at Wake Med. So let's take a look at UPS's technology around drones and delivering lab samples.
It's a small vehicle with huge potential. UPS and Matternet, a Silicon Valley drone company, are launching the first revenue drone delivery program in the U.S. at Wake Med Hospital in Raleigh, North Carolina.
UPS's interest in this technology has completely changed the game. When a company like UPS shows up and shows interest, it legitimizes the entire industry, and it really accelerates the entire industry.
The automated drone service is already underway, with flights every day carrying real medical samples.
We are using this pilot with Matternet and Wake Med Hospital to really gain learnings, work with the FAA and the DOT to really start to understand how we can drive technology forward in the future for different delivery modes and modes of transport.
Monitored by a trained drone pilot, the M2 drone can carry a 5-pound payload more than 12 miles. In Raleigh, it's being used to carry medical samples for testing at the hospital's main lab, reducing transit time from hours by ground courier to potentially just minutes, benefiting patients with quicker test results.
Drones have the potential to reshape the way we design our healthcare system.
This pioneering service is managed by UPS's Advanced Technology Group. Bala Ganesh, who leads the group, calls drones the tip of the spear in the company's transformation efforts.
What you're seeing is transformation in action, right? It's going to play over the next 4 or 5 years, but today is a stepping stone, that first step to getting to that journey.
The initial service involves short hops between 2 buildings on the Wake Med campus. But as the project advances, drones will connect the hospital with other Wake Med medical facilities miles apart. And UPS is talking to other hospital systems about drone technology as well. Drones are the latest innovation by a company that has been evolving for almost 112 years. Ganesh says UPS founder Jim Casey would be proud.
And today, I think if he were alive, he would be looking and saying, man, this is awesome. This is something we need to be a part of as we go forward.
So as you can see here, wireless networking, drone technology, really contributing to those important aspects of logistics, distribution, transportation, and maybe even decision-making and design. We start to think differently about logistics. We start to think very differently about logistics processes. So that's just a subtle reminder to be filling out your scorecard in terms of what you think the impact might be and what you think the ability to implement might be there. Certainly in Wake Med, they've benefited and really realized a lot of advantage in using drone technology, short-range, high bandwidth wireless networks to really coordinate a lot of their logistics efforts in the medical supply chain. Biotechnology, speaking of the medical supply chain, is revolutionizing how we think about living cells. This is applying digital technology, engineering, chemicals, science to living things, our living cells. It's amazing what is going on in this aspect of technology. It's amazing what it means for our health, our well-being, and also what it means for the environment. Quite amazing. So let's just go and take a look at some of the real revolutions here. Again, this is just a greatest hits. There are many, many more technologies that we could talk about in each one of these buckets. But stem cell therapy, the idea of regenerative medicine, this is taking stem cells, which are cells that have yet to be programmed, and turning them into useful cells. So the idea here is that a stem cell might become a lung cell or a heart muscle cell. And so something that has been damaged, like the lungs or the heart, can be regenerated through stem cell therapy. This is really important when you think about COVID-19, you know, something that we're very aware of right now, respiratory disease that basically destroys the lungs. Can those lungs be regenerated if the patient can survive? Can they go back to their original strength in terms of lung capacity, or in the terms of heart disease, their heart capacity? So let's take a look at stem cells and how they're being used.
You're looking at a few hundred cells here that are working together.
The heart muscle cells that Dr. Tim Nelson views highlight recent advances into regenerative medicine.
The simplest way to explain that is it's the opposite of degeneration.
Tissues in your heart, joints, and other areas can degenerate or break down with time or disease. Regeneration is the renewal of those tissues, which is something the body does naturally.
So one strategy is to try to find ways to improve the healing of your body, and another strategy is to actually supplement or augment the stem cells in your body so that we can improve the healing by transplanting stem cells into it.
Dr. Nelson and his colleague Dr. Andre Terzik use stem cells in their research because stem cells are responsible for growing new tissue.
So stem cells just means that they're seeds that can grow into many, many tissues.
Stem cells can come from a variety of places: embryos, which are not generally used anymore, umbilical cord blood, or adult bone marrow.
So the type of stem cell will dictate how many different types of tissues can emerge out of it.
Scientists can engineer stem cells into the type of cells they want. Here's how it works. Cells called fibroblasts are removed from a patient's skin. They're reprogrammed into what are called pluripotent stem cells. Those cells can be taught to become any type of healthy cells, such as these heart muscle cells. The idea is that the newly engineered healthy cells, when introduced to, say, those of a failing heart, will help restore or regenerate the function of the unhealthy cell.
This is one cell that's contracting, is working with many cells, and that gives the whole tissue the contraction pattern like a normal heart.
It becomes much more real when you have a personal connection to a disease or an illness where we don't currently have good options. And this is where people are asking more and more of the questions, what about stem cells?
The answer is researchers such as these at Mayo Clinic push forward to make regenerative medicine a reality for patients searching for successful treatment and perhaps cures. For Mayo Clinic News Network, I'm Vivian Williams.
So much good news, so much exciting technology and exciting breakthroughs in regenerative medicine. Well, this leads us to perhaps a controversial, but also a potentially impactful type of biotechnology, gene editing. And this is the idea of taking DNA, strands of DNA, which is basically the blueprint of you and I, and actually re-engineering that DNA. So here's a slide that really shows you how it works. Basically, you get a cell that is defective, something that is abnormal, something that is not working the way it should. And what we can do is take that strand of DNA and we can remove it and replace it with a healthy DNA strand. The technology that does this is CRISPR-Cas9. Now, when you think about how this might be used, this is one of the breakthrough technologies in treating cancer. The idea that cancer will manifest itself as a DNA strand that is not properly designed or that's not healthy, and that strand can be removed and replaced with a healthy version. So the idea is that if someone has a DNA sequence that is a predisposition for something like pancreatic cancer, that can be corrected. And of course, the earlier, the better. So it is controversial in the sense that you are re-engineering the blueprint of life, if you want to think about that. But the impact to basically eliminate childhood diabetes, to eliminate respiratory defects, to eliminate the possibility of cancer before it occurs is really revolutionary. The person that leads this effort is Jennifer Doudna, and she's quite articulate about the technique and quite enlightened in terms of its ethical issues. So let's hear from her about this new technology, CRISPR-Cas9.
I think the thing that's amazing about science and about biology for me is that there's always more to be discovered. And every time we feel like we've figured something out, it seems to open up several more questions. Scientists have appreciated for a long time that once we understood the DNA sequence in cells, if we had a tool that would allow easy manipulation of that sequence, that would be a very powerful kind of technology. CRISPR is a technology for changing the sequence of DNA in cells in a precise fashion to correct mutations that might otherwise cause disease. It's going to enable a lot of science to be done that was impossible to do in the past. So the way the CRISPR technology works is by the action of a protein called Cas9 that functions like a molecular scalpel for DNA. The CRISPR-Cas9 system has an amazing ability to recognize a particular DNA sequence in a cell that may be malfunctioning and then disable it by cutting the DNA. We call this gene editing, and we can use it to disable or repair a mutated part of the gene which may be causing disease. For Cas9 to find the malfunctioning DNA, we attach it to an RNA sequence that matches the DNA sequence we want to edit. Then we put this RNA-Cas9 combination into the cell. It finds the mutant DNA and uses a chemical reaction to cut the DNA strand right at the spot where it's malfunctioning. After that, we can sometimes insert the correct version of the gene for the cell to work properly again. It's a very exciting technology that's going to do a lot of good in human society and for human health. It stretches from human therapeutics to agricultural applications to thinking about how do we make better biofuels. These would be incredible outcomes, I think, of using this kind of technology in the future.
Wow, absolutely amazing when you think about the potential and when you think about how it might be used, everything from energy all the way to treating really terrible diseases in totally different ways. Well, one of the things that's really interesting about biotechnology, and if you think about a health supply chain, which I think is going to become even more important in logistics, is the explosion of bioinformatics. Again, pervasive computing that is collecting information about us, medicine that now has the ability to collect even greater information about us, is really going to create an explosion in bioinformatics. And the idea with bioinformatics is that through computer science, chemistry, biochemistry, you can see the different rings here, mathematics, we can really start to get information about ourselves. We can compare it to information from our ancestors through sites like 23andMe and Ancestry.com, and we can start to build probabilistic models about our health and about our welfare. Now, don't be afraid of this. This is actually something that might be very beneficial if it can be known very early that you might have a predisposition, let's say, towards skin cancer. It can certainly give you information about ways to protect yourself in the sun, things that you can do perhaps to lessen your statistical probability to develop something that might be harmful to you. So this is going to create a world of information, not only about us, about our health, but also probabilistic information about our walk through life. So let's take a quick look behind the scene of bioinformatics.
Life sciences are gradually being dominated by big data. By 2025, it is expected that the genomes of 1 billion people will have been sequenced. In other words, we are likely to generate somewhere between 2 and 40 billion gigabytes of genome data within the next decade. And that's only the human genome data. Life sciences can nowadays also obtain measurements on millions of proteins, metabolites, and their interactions. To make sense of enormous volumes of complex data, interdisciplinary researchers are needed to combine knowledge from biology, computer science, and statistics. Forming an essential component of modern-day life science research, this field is known as bioinformatics. One place where this work is carried out is at the Utrecht Bioinformatics Center. Studying the right data can lead to truly groundbreaking discoveries. By analyzing millions of DNA sequence fragments through high-performance computing, we were able to bring to light new unknown organisms. By identifying the 0.1% of a human genome that differs from person to person, we can explain just why two people never look the same. And by predicting the structures of proteins in a cell, we are beginning to understand why some of us get sick while others live long, healthy lives. These are the reasons why Utrecht Science Park promotes the sharing of bioinformatics expertise and the combining of different disciplines. Together, life sciences and big data can help us address the challenges of tomorrow.
Well, as you can see, it's an amazing world when we start to think about bioinformatics, when we start to think about all the information that will be collected about us as we live, that can be compared to those that have lived before us. And we can start to understand statistically more about life itself. Well, moving on now to another technology that I think is, to me, the rock star right now of a lot of the technologies, additive manufacturing, which is really an interesting technology because it's a computer and a chemical revolution. What's really driving a lot of the additive manufacturing applications now aren't so much computer-based, they're really chemical-based, new polymers, new resins, new types of technologies from the chemical sciences that allow us to create adhesives, that allow us to create polymers, steel, a lot of different things that at one time were basically seemed impossible. So if you take a look, 3D printing really works like this. A computer rendering, a 3D rendering is generated digitally. That digital rendering is then stored in a file, which is then given to a 3D printer. A 3D printer uses filament and other chemicals, other resins, to actually create the 3D image of that computer file. Here you can see the beginning and the end. The 3D computer file that is then created by the 3D printer in a couple of different sizes. 3D printers are now very, very small. They are ownable. There are 3D printers that are like personal computers used to be at one time. They can sit on your desktop. Now, what's really interesting about this is the design application and the decision-making application. When I think about the matrix that you guys are filling out as I'm going through this, that certainly really starts to make me think about that and the storage aspect of it. Perhaps we can print on the spot rather than store parts. Distribution becomes different because we can now distribute 3D printers where we distributed inventory at one point. So, lots of different things that are made possible through 3D printing. Certainly one of the things that's interesting is the size of 3D printers now. Here again, this is an industrial application where you can print huge parts. You can also print with very, very high tolerances, wings, helicopter rotors. These types of things can now be printed with more precision and with different types of materials to improve efficiency. What's really interesting about 3D printing is certainly its aspect or its contribution to sustainability. Through traditional manufacturing, certainly you create a lot of scrap. You have to get a lot of raw material. So certainly acquisition changes in 3D printing. Additive manufacturing, you start with foil, powder, or filament, and you create the part. Very little, if any, scrap. So it really revolutionizes that aspect of the process. And here you can actually see the impact of 3D printing on energy use. You reduce energy use by 50%, and scrap costs certainly result in 90% reduction. So quite a revolution. Now, what's really also interesting about this is that 3D printing is not just a technology that you have to bring in and build internally. It can be a service. There are a lot of service organizations that are popping up. One of them that I think is absolutely incredible is called Shapeways. So let's take a look inside of what Shapeways does as 3D printing as a service.
3D printing is a technology that lets you take a digital file and turn it into a physical product.
Almost anything you can imagine, people are creating. I think it's going to open up whole new opportunities in areas of mass customization.
Unlike with music or movies, with a 3D printer, a lot of things that are printed aren't protected by copyright.
One of the really cool things about 3D printing is it really changes the dynamic of a consumer culture. It turns you from being a passive consumer to an active creator.
3D printing is this amazing new technology where you can take a 3D digital file and with the click of a button, use that file to create an actual physical 3D part. So how does a 3D printer work? The first step is to get a 3D file, and you can get your 3D file in one of two ways. One, you can simply download the file from the internet. The second way is you can design your own 3D part. The software is going to slice your part up into layers. By building a part layer by layer, you're able to create a plastic part in 3 dimensions, and the possibilities are limited only by your imagination. People will create their next big invention, or engineers and designers create small production runs or little prototypes. Teachers can use it to print out teaching aids. If a teacher is doing a little lesson on a ship, they can actually print out a sailing ship and pass it around the class, and people print out things for around the house. iPhone cases are pretty big. You break a towel hook, you can print out a new one. We want to make 3D printers at a price that the average person can afford and also easy to use. We're already seeing late stage early adoption of 3D printing, but for me the exciting thing is what's to come.
Shapeways is an online 3D printing community and marketplace. Anyone in the world can upload their 3D model and we'll print it for you. And then also, if you decide you want to make it for sale, you can sell it and we'll produce it on demand for that customer wherever they are in the world. You can essentially bring a product to market with no risk. You don't have inventory anymore. You don't have to make sure that there's a market ready for your product. If you sell one, that's awesome. If you sell 10,000, then all of a sudden you have a passive income model, and that radically changes the economy. Usually to bring a product to market takes a year, and then you have to find the manufacturer and the investor, and so it's going to force us to change the way we think about not only buying products but how they're made. One of our colleagues broke his stroller, and it would have cost him something like $250 to get that part in the mail from the stroller company, and he literally just 3D printed a stroller part and got it for $20. You have this explosive technology where everything is made just for you, but at the price and quality of something you buy in a store. This could be a scary technology for for some companies, because what does that mean for seasons now? You have infinite inventory, and what does it mean for scarcity, which is one of the core tenets of so many industries? I think it's very similar, though, to social media or other tools of engagement where you're afraid to see what that would mean to let consumers co-create with you, or to really rethink your traditional manufacturing process because you have so many middlemen. I think we just have to stop thinking that you need to reach 100,000, 1 million people for something to be successful. Customization is really changing the way that we have to think about design and production as well.
People who make money by selling things that are all of a sudden easily copied with a 3D printer are going to be worried that people are going to be making unauthorized copies with those 3D printers. And I think one of the challenges for them is going to be, well, how do I react? Objects that are artistic objects, that are objects that you would hire an artist to make, those things are all going to be protected by copyright. But those objects that actually do things, that have a use besides just sort of entertaining or looking nice, a lot of those are going to fall outside of the scope of copyright. They might be protected by patent, but a lot of them won't be protected by any sort of intellectual property at all. And as a result of that, you can use them or improve upon them or build on them as much as you want, and no one can stop you. 3D printing right now is at its very beginnings. And so you don't have a lot of case law about everyday people making exact copies of physical objects, and certainly not a lot of case law about people being able to do that on a large scale. The good thing, hopefully, is that the industries that are disrupted by 3D printing have the model of the music industry to maybe learn from. The music industry, when someone started copying things, decided the best thing to do was take their time and their money and invest it in suing everyone they could find and try and stop the progress of technology. That didn't work very well. And so the hope is that these creators, when they see this new technology, they capture some of the upside and they say, oh, wait, this can change my business for the better. And they do that. It's a hard thing to do, but the music industry has taught us that it may be the thing they have to do.
3D printing is going to have a profound impact on all of us, whether you consider yourself a designer or not. In the future, there are going to be 3D printers that will allow you to actually create three-dimensional structures out of living cells. And they can build very complex structures like blood vessels or skin tissue. And the idea there is that in 10 or 20 years, these scientists are going to be able to 3D print tissue that can replace damaged vessels of the heart, or they're going to be able to print replacement organs. So you won't have to go to find an organ donor anymore. You'll just be able to have one 3D printed at the hospital based on your own cell and your own genetic makeup. Right now at MIT, scientists are working on 3D printers that would actually allow you to print food. And who wouldn't want that in their house, right? If you could just ask Siri to cook you a steak. I mean, it's really going to be an exciting time in the home. In Japan, there's a company that's taking sonogram data. So they scan a pregnant woman's belly, and they're able to actually 3D print a figure of her torso. So instead of just having a fuzzy little black and white picture, you're getting a real model of what your child is going to look like. People are using 3D printers to do all sorts of interesting things in terms of the environment. Researchers are using 3D printers that can print concrete to make replacements for parts of the Great Barrier Reef that have been damaged. Normally, those reefs take thousands of years to build, but what these scientists do is they find the areas that are damaged, they make CAD replicas of those damaged areas, and they print them in concrete. So it's a base structure upon which coral can create a top layer, and that helps reinvigorate the environment and helps return normality to that area. I mean, one of the coolest things about 3D printing is that it's a community that never stops innovating. There are hundreds of innovators who are making little tweaks to these products, who are trying out different things, and so it really gives everybody an opportunity to create anything they could imagine.
3D printing is the next wave of how brands and consumers can engage, and now we're just starting to see that happen.
In a few years' time, they're going to be no more difficult to use or difficult to understand than a camera phone.
The way to protect creators and designers is to make sure to give people a way to spend money on 3D printed things.
In the future, we're going to see a lot more people unleashing their pent-up creativity, and that's what's most exciting for me.
Absolutely amazing. And again, they're not the only one in the business. There are a lot of vendors that are out there now as far as 3D printing as a service. And here you can see just a few that I've listed. Look at some of the products that they're able to make and some of the businesses that are formed. Shapeways combining with Etsy. The idea here being that inventory is only created when an order is initiated. Certainly personalization of everything from bobbleheads to statues of people, even songs that have been captured here you can actually see in analog waves within a glass structure here. Adele's song, Someone Like You, is captured in terms of its sound waves. So you really see a lot of innovation, a lot of things that are really unique and novel when it comes to 3D printing. And we've only just begun. I think you're going to see a lot of revolution, a lot of different things in 3D printing that really you've never seen before. An amazing technology.